welcome back. In this lecture we are going to discuss the types of EV. You normally hear about several types of electric vehicles. There are hybrids, plug-in hybrids, battery electric vehicles and many others. In this section we will talk about the types of EVs and you will learn how to identify an electric vehicle type. Vehicles can be classified based on drivetrain and fuel types such as the conventional internal combustion engine vehicle, the alternative fuel internal combustion engine vehicle, and electric vehicle. The internal combustion engine is commonly referred to by its short form ICE. The conventional ICE vehicle includes the gasoline and diesel vehicles. The alternative fuel ICE vehicle refers to vehicles that run on fuel other than gasoline and diesel, like autogas, natural gas, biofuel, or hydrogen. In all forms of ICE vehicles, the drivetrain is mechanical. In contrast, electric vehicles use an electric drivetrain for their propulsion. In this lecture we will focus on electric vehicles. While battery electric vehicles have an electrified drivetrain, they can be classified based on their energy sources, their propulsion devices, and how their propulsion devices are hybridized. In general, we have hybrid electric vehicle (HEV), plug-in hybrid electric vehicles (PHEV), battery electric vehicle (BEV), fuel cell electric vehicle (FCEV), and in future solar EV. The hybrid electric vehicle sources its energy solely from gasoline or diesel, while it uses both the electric motor in combination with battery and combustion engine for propulsion. The plug-in hybrid electric vehicle is similar to hybrid electric vehicle that it uses both an engine and electric motor for propulsion. The difference is that the battery of PHEV can be charged by electricity via charging ports. In contrast, the battery electric vehicle does not have an engine and is purely powered by electricity instead of fossil fuel. Further, the propulsion is solely driven by electric motor. Finally, in the case of fuel cell and solar electric vehicle, the energy is directly sourced from hydrogen using fuel cell or from solar panels respectively, while the propulsion is done using electric motor. Now let's look at these vehicles one by one. For reference, let us start with gasoline and diesel vehicles that use internal combustion engine for propulsion. A gasoline car typically uses spark-ignited engine rather than compression-ignited systems used in diesel vehicles. The engine uses complex mechanical transmission system to transfer power to the wheels, similar to gasoline vehicles. Hybrid electric vehicles are powered by internal combustion engine as well. However, in addition, an electric motor can propel the vehicle by using energy stored in the batteries. The battery is in turn charged by drawing energy from the engine by using the electric motor as an electric generator. To operate the motor and generator mode, a clever power electronic motor drive is used. The extra power provided by the electric motor allows for smaller engine. Further, the motor allows the engine to be operated in its optimal efficiency point, resulting in the battery fuel economy. What we have just seen is a parallel hybrid architecture where both the engine and the motor can power the wheels at the same time. A series hybrid electric vehicle, on the other hand, works differently. The internal combustion engine is used to drive a generator to provide electrical power for the traction motors and to charge the battery. This is a common propulsion method which has been used in the locomotives for many years. The traction motor is the only power supply unit with the direct connection to the wheels. The advantage is that the internal combustion engine can be operated at its most efficient point to generate the necessary current for driving the traction motor or charging the battery. The third type of hybrid is the series parallel or dual mode hybrid. This has the flexibility to operate in either series or parallel mode by using power split. It has generator to charge the battery as seen in series hybrid, and it has the engine and the motor simultaneously powering the wheels as seen in parallel hybrid. Although this type of architecture is more flexible in terms of driving modes, it is also more complex and of course costly. The Toyota Prius is example of hybrid electric vehicle based on the series parallel architecture. Plug-in hybrid electric vehicles are similar to hybrid electric vehicles in that they have both an engine and motor for propulsion. The main difference lies in the fact that PHEV batteries are larger and can be externally charged using the onboard charger. This is beside the fact that the battery can be charged using the internal combustion engine while driving. This enables the PHEV to use the electric motor during large periods of time when driving. That means for large distances. This means that the PHEV can drive electric for most city commutes and switch to fossil fuel for long highway rides, removing any range anxiety. What is shown here is PHEV based on parallel drivetrain architecture. Similar to what was seen before, PHEV can be built based on series and series parallel architectures as well. Chevrolet Volt is example of a plug-in hybrid electric vehicle based on series parallel architecture. The disadvantages of HEV and PHEV is that they continue to use fossil fuel and hence have tailpipe emissions. To overcome this, the battery electric vehicles only have an electric motor and no internal combustion engine. The vehicle uses a large traction battery pack to power the electric motor, and the battery must be charged from power outlet when it is parked. The Tesla Model S is example of battery electric vehicle. Next, we'll look at the fuel cell EV. A fuel cell electric vehicle substitutes the large battery of battery electric vehicle for a fuel cell stack to generate electricity from the hydrogen fuel. Unlike a battery, a fuel cell is not a storage device, but a component that produces direct current from chemical reaction. A small battery is still used as the energy buffer and to power the electric motor using the motor drive. A fuel cell vehicle has the advantage of short refueling time and extended driving range when compared with battery electric vehicles. Here is an example of fuel cell electric vehicle.